So these are the numerical based upon error analysis. Type B, error in sum of the quantities. This is the type. Okay, so if C is equal to A plus B, if C is sum of A and B, then error in C will also be sum of error in A and error in B. So if C is sum of A and B, then error in C would be sum of error in A plus error in B. So let us see the first numerical of this type. So you can see here two different masses are determined as this gram. So this is your mass 1. This is main value 23.7, and what is written with plus minus, that is your error in mass. Okay, so that is del m1. So it is 0.5 gram. Similarly, this is mass in second quantity, matlab mass of second quantity, main value, and this is error. So this is error in second mass. It is 0.3. We have to find out the sum of their masses. So sum would be add up the main values like A plus B. So add up the main values 23.7 plus 17.6. You can add it up. Okay, so it is coming this much gram obviously. Now this is sum. Error in sum would be sum of errors. So it is 0.8. So how would you represent the quantity? Final quantity would be written as, sum would be written as, like the sum of two masses would be written as this main value plus minus this error 0.8 closed gram. So this is the answer. Let us see the next numerical. These are two resistances connected in series. What is the equivalent resistance? So we know in series net resistance is sum of individual resistance. So it is a numerical based upon sum of two quantities. So net resistance you would find out by adding the main quantities. Here it is 100, here it is 200. So 100 plus 200, it is 300. Now this is ohm obviously. Error in net resistance would be sum of individual errors. Here it is 3 ohm, here it is 4 ohm. So 3 plus 4 is 7 ohm. Now the net quantity can be written as main value plus minus error. So this is your answer. Let us see the next. Now let us see the next type of numericals, error in difference. That is, if D is difference of A and B, then error in D would be sum of error in A and error in B. So yes, main quantities will be subtracted but errors would be added. So let us see the first numerical. The initial and final temperature. So this is initial temperature, main value 18, and error in initial temperature is 0.5 degrees Celsius. Similarly, second temperature is 40 and error in second temperature is, you can read here, it's 0.3 degrees Celsius. So everywhere units to be written. So what is the rise in temperature? Rise, what is the rise, what is the fall, what is the difference in temperature? So it's a numerical based upon subtraction of two quantities, right? So rise in temperature would be, you can write rise in temperature is final minus initial. Main values will be subtracted. So it's 40 minus 18, that is 22 degrees Celsius. But main values will be subtracted, but error in rise in temperature would be the addition of two temperatures, zero point 0.5 and 0.3. So it's 0.8 degrees Celsius. So how would you represent the final result? This is the rise in temperature plus minus this error, degree Celsius. Let us see the next. If A, this is A equals this, so this is main value, let me do it, and this is error in A. Okay? This is B. We have to find out addition of A and B. So first part I'm solving. So we have to find out A plus B. So first part, A plus B main values would be added. 12 plus 8.5. So it is 20.5. Right? Unit, okay. And then errors in sum would be addition of the two errors. That is 0.1 and 0.5. That is 0.6. So you can report the result. But in case of subtraction, we'll have to find out, you can see, second part is A minus B. Second part is A minus B. So main values will be subtracted. 12 minus 8.5, 3.5. But error would be added. So you can say it is still 0.6, and this is how we report the answer. Main value plus minus error. But it has to be duly solved, like show the steps of addition. So coming to next. This is temperature 1. This is temperature 2. We'll have to tell temperature difference. So temperature difference would be the subtraction of two upper value, final temperature minus this. So it's 30. But error would be added. 0.5 plus 0.5 is 1. So error is this. You can report the answer like this. So let us see the next question now. This is length 1. This is length 2. We have to find out the difference, subtraction. So 15 minus 2, upper, bigger reading minus smaller reading. You can subtract, but error would be added. So you can match up the answer here. Error is added. So let us see next. So it is also same. Try this numerical. L1, L2. We have to find out the sum. Sum 10 plus 9, 19. Error is added. 0.2. Difference 10 minus 9 is 1, but error would be added. Okay, so getting to next. And they're asking percentage error in each case. तो percentage error कितना हो गया यहाँ पे? ये 0.2 है ना, will multiply with 100. ठीक है, तो it will be 20%. Here also 0.2 multiply with 100, so 20%. So getting to next. See, this is some other type of numerical. So whichever I have discussed, that you will do in this type. So let us discuss the next type of error-based numericals now. Type C. Now let us see the next type, in which numericals are based upon multiplication of quantities and division of quantities. Okay. So main terms will be multiplied in multiplication. And division, main terms will be divided. but error is reported in such a way. For both, it is same. Multiplication and division, we have common formula that your quantities relative error would be sum of relative error of A, first quantity, relative error of second quantity. This is how it is for both multiplication and division. We'll gradually understand with numericals. So let us see. Let us see this numerical. Length, breadth and height of a rectangular block of wood were measured to be this and this, and height is this. So this is main value of length, main value of breadth and main value of height. And error in length is this value, that is 0.02 centimeter. Error in breadth is this 0.01 centimeter, and this is error in height. Just keep the values separate. So we'll have to find out the percentage error in volume. So volume is equal to length into breadth into height. So it's a numerical of multiplication. So multiply the main values. That is 12.13 into 8.16 into 3.46. Okay, we will multiply if it is required. Right now it is not required. So let us see. Further, we have to find out the percentage error. Okay, so we will write the formula of relative error. Right now what we have in multiplication and division, we have this formula that relative error will be sum of individual errors. There are three terms. So relative error in length, this is relative error in breadth, and this is relative error in height, and this is relative error in volume. So it will be sum of all three. Okay, so we will substitute all the values here duly. Del L is this, substitute 0.02, here del B 0.01, and error in height is how much? 0.01. Now let us substitute the main values. So let us substitute the main values. Main values, you can see it's this, this and this. Substitute. This is equal to relative error in volume. But we have to find out percentage error. So just simply multiply this side with 100 and this side with 100. So this becomes your percentage error in volume. Percentage error in volume is coming as, divide these, multiply with 100, you will get it as, divide these, add up, okay, like decimals you have to remove, or decimal is getting cancelled, so it's 2 by 1213. Similarly next, okay, means division you do on your own, and it will come as approximately 0.58%. So this is percentage error in volume, but then for you division is most important. Divide, add up, check your mathematics at every step. So let us get to the next numerical. So let us see this numerical. Resistance is equal to V by I, that everyone knows. Voltage is this. So this is main value, this is error. 5 volt is error in voltage. This is error in current. We have to find the percentage error in R. So again, relative error in resistance is equal to sum of, though the numerical is of division, sum of individual errors of the quantities voltage and relative error of current. Its relative error is equal to sum of relative errors of upper quantity and relative error of lower quantity. Now you can put the values simply. Let us substitute the values. This is 5, upper value is this 100 plus 0.2, this is 10. So you can divide and do it properly. This is 5 by 100, 0.05, and this is 0.02. So it is 0.07. So what is 0.07? Your left hand side is relative error in resistance. So this is the answer. But this is relative error. Okay, but we have to find a percentage error. So we'll multiply this side with 100 and this side with 100. So we'll get what is the name of this quantity? Percentage error in resistance is equal to, this is your 7%. So let us get to the next numerical. Let us see this question. Displacement is given as this, so that means you should be able to find out the error. So what is the error in displacement? 5 meters. Error in time, 0.2 seconds. So we have to find out the percentage error in velocity. Same. See, velocity is displacement by time. So it is a numerical based upon division. And in case of division based numerical, relative error in this side of quantity is equal to sum of relative error of upper quantity and then relative error of lower quantity. Now same, let us put the errors 5 and here it is 0.2. Put the main values. Displacement main value is 200 and times main value is 20. So this will be equal to relative error in velocity. Now divide peacefully, add, addition will come about 0.035. Okay, addition will come as 0.035. You do check your mathematics. So this is equal to del V by V. This is relative error in velocity. Now to find out percentage error, you will multiply like this. So this will come as 3.5%. And here you will write relative error in velocity. Let us see this numerical. Length and breadth of a field are this and this. Measured to an accuracy of this. So this is error in length also and breadth also. So error in length is this only, 0.2 centimeter. Error in breadth is also 0.2. Now main values have been given. You can see 22.4 of length. And for breadth it is 15.8. So we have to find the percentage error in area. So area is length into breadth. So it is a numerical of multiplication base. In multiplication also, answer is same as that of division. So relative error in area is equal to sum of relative error in length and relative error in breadth. Substitute the values del L, L, del B, sorry, B is this. Then divide, substitute the values, add, you will get something, right? When you will divide and add, you will get something. That will be relative error. Then you will have to multiply both the sides with 100. That will be percentage error. So that will be the answer. Here we'll tie this for 14th numerical. Okay, 13 is not to be done now. I'll cover it later with some topic. So here mass and volume. This is mass, main value. 2.00, that is 2 gram. Volume is 5 cubic centimeter. Errors have been given this and this. So this is error in mass, first value 0.01 gram. And error in volume is 0.1 cubic centimeter. What are the percentage error in density? So what is density? Density is mass upon volume. So it's a question of division based numerical. So relative error in density is equal to sum of relative error in mass and volume. Same thing is to be done. Substitute 0.01 divided by mass, this value 2, and here it's 0.1 and this is 5. So it will come as 1 by 50. Okay, and this will come as 1 by 200. Now the way you wish to add, you can add by taking LCM or by dividing. So you can see I have divided and I have found these values. 1 by 200 is this, 1 by 50 is this. Add properly. You should know how to add. Decimal below decimal. So it is, you can see relative error in density comes as 0.025. This is relative error. They ask percentage error. So we have repeated the steps with each numerical. So multiply with 100 on both sides. So it will come as 2.5%. So you can match here. This is 2.5. So here question number 4 is for your practice. Main value of length, error in length, main value of breadth, error in breadth. We'll have to find out area of the rectangle. Area. This time they are not asking percentage error. They are asking area. So area would be multiplication of main values. That is 5.7 and 3.4. Sorry. 5.7 into 3.4. You can multiply and you can write as centimeter square. Now you have to find out the error. This numerical is different from the rest of multiplication and division type that we have done, but is important. So multiply these two, 5.7 and 3.4. It is coming as 19.38. You can take 19.4 also, but it's okay. Now we have to find out the area with error. So you would use same formula, that the relative error in area is equal to relative error in length plus relative error in breadth. Substitute values. Del A we have to find out. A we have found as this 19.4. If you wish, you can write. What is del L? You can see here it's 0.1. And what is L? 5.7. Then it's del B is 0.2. Breadth says 3.4. Substitute. Now divide these. Okay, so you can divide these values like this is coming as 0.0175. Similarly, you divide the next. Point would be cancelled. So basically it is 2 by 3.4. 34. That is coming as 0.058. Add. Now this is del A by area. Area is 19.4. Add up these two. Multiply with 19.4. That will be coming as area's error. That will be del A. After multiplying the addition of these two with 19.4. Then report your answer. How to report your answer? You got a main area. So area, see, you can see main area is this, plus minus whatever error you are getting. So this numerical is different. They are not asking percentage error. Substitute these values, divide, add, multiply with main area, you will get error. So you can report the answer like this. So kindly prepare these numericals.